Good afternoon. First, we are called now Zuz. A week ago, we branded. Our previous name was Chakratech. So many people know us in this name. We are focused on ultra-fast charging and specifically installation of ultra-fast chargers in area without strong grid. Here you see a typical station. You see two fast chargers and this box, which is a, a power booster. And basically, the system is installed in a place where the grid power cannot support those two chargers. By adding this box, the power booster, we can support them and actually install a fast charging station almost everywhere. We'll start with a short movie with customer feedback.
In Vienna, we as Wien Energie, one of the largest suppliers for fast charging stations. Right now we only have around 20 of them. It is a very difficult thing to put up fast charging stations in urban areas like Vienna. This is due to the grid constraints, because the electricity grid, of course, was not built. For example, Tesla as well only has one supercharger site in Vienna. So we have a lack of fast charging stations and we had to find a solution for this challenge.
The infrastructure at the Vienna airport doesn't allow for fast charging. So we got a mission and a challenge from Wien Energie, the local utility, to enable to charge this car very fast. The Tesla car is now connected to a fast charger, although the power is not strong enough. We have brought here our kinetic power booster. This power booster is boosting the fast charger, giving him the additional power which is missing from the grid. By that, we allow this fast charger to charge the Tesla instead of in 1 hour, in 15 minutes, and giving him additional 250 kilometers driving range in those 15 minutes. The way we are doing it with our kinetic power booster is totally sustainable, based on our flywheel kinetic technology and not on chemical batteries.
We chose Chakratech because they had a promising, simple and environmentally friendly solution. Right now we're in talks with Chakratech about a second system that we want to put up at our headquarters, because there we have the problem that we cannot expand the grid right now, and we need buffer storage for fast charging stations.
The number of EV chargers in Aalborg is very low due to the fact that we have a little challenges like everybody else. EV chargers is going to be a great success for the pollution or for the green environment. And Aalborg is the main capital of green investment in Northern Europe. We are here in Chakratech to see the possibilities that Chakratech have shown us. I'm very impressed with the Chakratech solution, and I think this is a very good setup, very sustainable and very doable over time, and has definitely some benefits that we look into in the future.
Premier Inn ist eine Premium Economy Hotel Marke, hat in Großbritannien mehr als 800 Hotels. Hier in Leipzig, wir sind ja mit dem Hotel mitten im Zentrum. Das heißt, die Stadt hat uns einen Transformator zur Verfügung gestellt, um unser Haus zu versorgen. Wir wollen aber auch für unsere Gäste zukunftsweisend sein und somit auch für Elektrofahrzeuge Ladetechnologie anbieten, haben aber diese freie Kapazität nicht und mussten uns nun nach alternativen Möglichkeiten umschauen. In diesem Punkt hat die Erfahrung hier in Leipzig mit Chakratech Früchte getragen, sodass wir uns gut vorstellen können, die kinetische Speichertechnologie von Chakratech einsetzen zu können, um einfach unseren Gästen eine tolle Ladeinfrastruktur anbieten zu können.
After successfully operating this live system at the Vienna airport, we are expanding to Germany. We have adopted this system to the US standard market, and from there we are going on, and I'm very optimistic for the future because the problem is not just in Vienna. The problem is all around. We will need to put fast charging station there. There is not enough power, and we are solving the problem.
So we are focusing on the fast and ultra-fast charging, and in the future, we will have the ultra-fast charging, a 450 kilowatt charger that could charge a car in 5 minutes. It's clear that the grid cannot support such chargers. Grid upgrade is very problematic, takes a long time, complex, and is very expensive. In order to do it, basically we introduced this power booster. From one side, we see the grid, which is weak. From the other side, we see the ultra-fast charger. The principle of the work principle of this system is as follows. The power booster is slowly charged from the grid, and when a car comes, we charge it very fast, so it could be a charge at the full speed of the charger and not related to the power that is given by the grid itself. This is our system, the Zooster 100. It includes 8 flywheels. We store the energy inside the power booster in a very unique way. Instead of batteries, we use flywheels. And the main advantages of the flywheel is A, it does not degrade over time. B, it's totally green. And C, is a totally safe and not prone to fires. The principle of operation is as follows. We have a mass inside. Once we charge from the grid, the mass accelerates until it reaches its maximal speed. The energy is stored as a kinetic energy. Then we are waiting for the car. Once the wheel is rotating with very low friction, floating on magnetic bearings and in vacuum. When the car comes, the motor turns into a generator and energy transfer from kinetic energy into electricity into the car. Why this system has advantage over batteries? Batteries has a tendency, as you charge and discharge, you have degradation of the battery. In this application, we have about 15 cycles per day, which means more than 5,000 cycles per year. And that means you will have to replace the battery each year. In our system, as you can see in the graph above, there's no degradation. The system lives without losing any capacity for 20 years, so there's no need to replace it. And this gives the economic advantage that although the capital cost of the system is higher than a battery system, the cost per cycle and the total cost of ownership is about 1/2 to 1/3 compared to a battery-based system. A little bit about the market. Fast DC systems, chargers, are not the most common chargers. Most of the people know chargers at home. The ratio between the number of cars and the number of fast DC chargers is about 1 to 100. Most of the people will not use those chargers unless they go to vacations. Most of the users of those chargers are commercial cars. So if we expect by the end of the decade about 150 million electric vehicles, they're going to be about 1.5 million fast charging ports. The estimate is that about 25 to 30% of those will be positioned in places that the grid cannot support them, which means about 500,000 units will need some kind of a power booster or some other means to support and add them power. And this represents a market of about $60 billion. We expect to catch significant part of this market, mainly in the European and the North American market. Thank you. A little bit about installation coming soon. We have this year, we have 2 systems installed in Germany. We plan to install 10 systems this year, 8 of them in Germany and in Austria, and 2 in North America. Thank you.